Hello guys, welcome back.
Yeah, so we'll be solving the second CSES question today. This question has a very elegant solution and also a brute force solution. We'll discuss both of them. So let's move on. So the question says that consider a two-player game where each player has n cards numbered from 1 to n. On each turn, both player places one of the cards on the table. The player who places the higher card of gets 1 point, and if they are equal, neither of them get the point. The game continues until the end. Finally, you are given the n, the number of cards, and the player's score A and B. Let's say player 1 has scored A points, player 2 has scored B points. So your task is to examine how the game could have been played out using an example. So if it is possible to achieve such a score, then we need to print yes and a series of such sequence. In this case, there were 4 cards numbered 1 to 4, and player 1 won 1 times and player 2 won 2 times. So in here there will be only one sequence where the series above has a greater number than the series below. So as you can see, 4 and 1, this is the only sequence where the first sequence has a greater card at that position as compared to the lower series, and 2 times the upper card is lesser than the lower card. Upper card is lesser than the lower card, and the remaining 1 time will be same, nobody gets a point. So 3-3. So this is a question. So let's say this is player 1 and this is player 2. We'll visualize it. Okay, so let's assume that these are the cards, right, numbered 1 to n. I'm just laying them out in this sequence, and we'll do match the following. Like, let this as there is no sequence, right, we just need the final points to be equal to A and B. So there is no sequence, so we just need to find the combinations, which means for which card when player 1 plays, player 2, we just need to find a pair of cards, right? So let's say this card number 2 of player 1 is played against card number 7 of player 2. So this pair, in this pair, as player 2 has the greater card, player 2 gets a point. So we just need to find the pairs such that the scores are A and B. This is how I have visualized it. So how can we find a sequence such that we need A sequence where player 1 has the greater card, A sequence where player 1 has the greater card than player 2, and B pairs where player 1 has lesser cards, the card value is lesser than that of player 2. So this is what we need to find. So what I thought was, let's start a brute force method, that we'll start from number 1, and as let's say B cards. Okay, B pairs are required such that player 1 is on the lesser value, right? So I'll say that, let's say these are 2, 3, 4, 5 cards, and here also 2, 3, 4, 5. I've arranged them into a match the column type sequence, right, just for visualization. So I need B pairs where the player 1 card is lesser. So I'll start from 1. Let's say player 1 plays a card 1. So for that, I'll say let's just increment it by 1. So for 1, player 2 will play the card 2, and using this pair, we get a point B, one of the point of the B. Similarly, we need total B points, right? So we'll do B such pairs. Okay, got it? That means this upwards arrow, which differ by 1. Let's say here card was n, the card here will be n plus 1. That means I'll use a x card. Okay, if there was card x played here, I just play a card x plus 1 for the player 2, so that the point goes to the player 2 and we contribute to the B. Now we need a pairs such that player 1 is greater than player 2. Now the another brute force method could be that as we have started from 1 and going plus 1 here, that for 1 I'll pair it with 2, for 2 I'll pair it with 3. Now I need downwards arrow, right? Downwards arrow. Player 1 should be greater than player 2. Player 1 should be greater. That means I'll start from here, nth card, the last card, and I'll again apply the same brute force method. So just to make it just lesser, so I'll give it here, let's say n minus 1, n minus 2, here n minus 1, n minus 2. So I'll pair this nth card with the n minus 1 card. So this is a downward arrow. I'll represent it with another color. This is a downward arrow. This is a downward arrow. This is a downward arrow. Got it? So that is what the question is, that we need A of the downward arrows, B of upward arrows, and I'll represent it with blue. B upward arrows I've represented with color blue, and all the remaining cards should be equal. Let's say I'll represent them with this green arrow. So all the other n minus A minus B cards should be of the same level. That means a draw. No points is given to anyone. So graphically this is the question, that we need A number of downward arrows, B number of upward arrows. So this itself is the approach, right? What I explained, that we'll brute force it from 1 to how many upward arrows we need, and then we'll brute force it downwards, right? But as you can see here, there is a conflict, that this same number, let's say the number y, this number y is included in the pair with the number 5 also, and the one with the pair of n minus 2 also. There is a conflict here according to this logic. So this logic, we can solve it, no doubt. We can use some restrictions or some calculation or manipulation, and we can use this method, but it is complicated. You can agree, right? We need to add more conditions and constraints. It is complicated. So what my approach was, that there are n total cards for each player. That means there are n possible pairs. In that pair we need A pair which are player 1 is, let's say, greater than player 2, and then B cards which are player 1 is lesser than player 2, and the remaining n minus A minus B equal. So the equal part I'll get it over with, so we just had to worry about this. So let's say we have n cards, right? We have n cards from 1 to n for player 1, and for player 2 1 to n. This n minus A minus B cards needs to be equal, so I'll just give the pair to the top ones, so that we are just remained with some, let's say, n minus A minus B. This is the point where the card is n minus A minus B. This is n minus A minus B. So all these cards above that point, I'll arrange them. These number of cards I'll represent as this is n, and this is the point n minus A minus B. So the number of the cards here are n minus A minus B, and the number of cards till that point are A plus B. Is this this is mathematically correct, right? I assume that till here let there be A plus B cards which I have to worry about the sequencing, that what sequence I should get, either upward arrow or downward arrow, right? But all the other remaining cards, this n minus A minus B cards, from the value n minus A minus B to the value n, all these cards should be equal, right? Should be matched with equal value to the player 2. Now that is done. After we do that, we are left with this A plus B cards, and we need to arrange these A plus B cards. Let's say I'll give this A plus B a value of k. So let this A plus B be k cards, okay? K, I'm saying A plus B is equal to k. So this k cards, we need to find a sequence where there are A number of upward pairs, upward sequence, and B number of downward arrows. Right, and total there are k cards. So if, let's say, for example, I had number 1 to 7. 1, 2, 3, 4, 5, 6 and 7. I'll copy that this itself. Yeah, so these are the cards of player 1, these are the cards of player 2, and this is K cards. Okay, these are the K cards. All the cards above that have been matched equally. So we just need to worry about the K cards, which must be matched in such a way that either one should be lesser or greater. So for example, let me take that A is equal to 3 and B is equal to 4. If you can visualize it, that let's say we need 3 cards to match to 3 cards in a way that they should be matched in a upwards arrow sequence. So that will be, let's say these first 3 cards I choose. Let's say these first 3 cards contribute to the points of A. That means 3 points which are for upward arrow have been done by the first 3 cards by the player 1. So what all values possible combinations are there? That 1, the number 1 can be matched with any number higher than that, and that will give us the point. Similarly, the number 2 can be matched with any card which is above 2, so 3, 4, 5, 6, 7, and the 3 card can be matched with all the numbers above it, so till 4. So this is a sequence. As you can see, in each of the sequence, in each of this red sequence, green sequence and orange area, it always includes the top part, that it starts from the top itself, right? And from the bottom it goes on decreasing as we go on increasing the number. So we'll just use a brute force approach, that all these cards are paired, the first 3 cards are paired with the top 3 cards. That is a correct answer, right? So the first 3 cards are matched with the top 3 cards. So this is a match. Gives us a point. This gives us a point. This also gives us a point. This upward arrow gives a point in A. This upward arrow is a point for A. This upward arrow is a point A. And all the remaining cards, how many cards are remaining? If this was K, this was A plus B cards, and A cards I have already paired them. So the remaining are B cards, and similarly B cards, the top B cards will get matched with the bottom B cards. So it will be like this. So we have A number of upward cards and B number of downward cards. What was the logic? That the bottom A cards will be matched with the top A cards, and the top B cards will be matched with the bottom B cards. Okay. So that was the logic. This is the logic which I applied. Okay, so I'll show you my submission just a minute. So my submission was this, that for the first, I start all the numbers, right, from 1 to n. I'll iterate through all the cards. Let's say for player 1, I iterate through all the cards, and for the first A card, if I is less than equal to A, for the first A card I match it with the card which is at the top. Okay, that is a logic where just a bit variation is there. Instead of selecting the top A cards, let me write it clearly. Instead of using the top A cards for the first A cards, what I did was, that's the same itself. Okay, this is B, so this is the length is B, right? The total length was A, the total number of cards was A plus B, which is K. Total is K. From that, if I remove the A cards, right, if I remove the A cards, what I have the B cards from the top. So when I say that I need to match the first A cards with the top A cards, I can also rephrase this by saying that I'll match the first A cards with the card B above that. Let's say this is 1, right? This 1 is matched with 5. So this is B above the 1, right? So 1 is here and there are B cards here which I have matched to the top B cards. So I start matching the bottom cards, these bottom cards, from a height of B. After a height of B, I start matching them. So that is same. I have just rephrased it for you to understand it better. But the logic is same, okay? So for the first A cards, I assign them with the top A cards. For the remaining after A till B, that means for till the value K after A, I used else if, so only one of them gets executed. This is for the top A cards. This is for the cards after A till B, right? So this is what I matched with the bottom B cards. Total I minus A is the bottom B cards, and all the remaining ones I have matched it with the number itself. So these are equal, and finally I printed this too. This was my logic, but there's a even more elegant solution. I'll show you how. So that the part where we segregate it and we are remained with the K cards is the same. So let's say these are K cards, okay? A plus B is equal to K cards. So player 1 has K cards and player 2 has K cards. So if we rotate them, just a minute, let me tell you how I can explain it better. So these are the number, right? Let me give you by the number example itself. Let's say till 5 I have 3, 4, 5, 1, 2, 3, 4, 5. One observation is that when I rotate a sequence, that means I shift all the values to the right. What happens is that the lower values go to a greater position. So when I rotate this lesser value 1, 2, 3 are shifted towards the right, right? It is shifted towards the right to a higher position, and the higher position cards, due to rotation, they come at the start of the sequence, they come at a lower position. So what rotation does is that the lower value cards, I'll write it down, the lower value cards are shifted to higher position and the higher value cards are shifted to lower position. And that is what we needed, right? We need an inequality. It should either be lesser than or greater than. So let's say we shifted by 1, rotate by 1 position. So it becomes the original array is 1, 2, 3, 4, 5, the original sequence. Let's say I rotate this by 1. So it becomes 5, 1, 2, 3, 4. As you can notice, all these lesser numbers have come to a higher position than it previously was. It was previously here for the first 4 numbers, now it has come to the last 4 numbers. And the greater value card has rotated and come at the beginning, so it has come to a lower position. And if we plot the inequality here, so it becomes greater. So we are left with 4 greater value signs and one of the lesser value sign, right? So that means when we shifted by, let's say, A numbers, we get A number of lesser than signs and we get the remaining, which is K minus A, which is equal to A plus B minus A, which is equal to B. The remaining B cards, we'll get it of the greater sign. That is what we needed. We need A lesser than sign and B greater than sign. And this can be achieved by just shifting the sequence by A cards. So that is the elegant solution. That is what the question was meant to teach us. That when we rotate an sequence, this elegant observation can be made. So I hope you guys understood this. See, I also was not able to get this, but I have learned this now. So whenever I think I will get to when I will come up with an even more elegant solution, this will be a part of it, because now I have seen this one, so I can rethink of this has been added to my artillery now. So that is what we need to do. We just need to learn and gather all the knowledge and observations we can get. That is CP. So thank you guys.